Hi, I'm Professor Nashiba, and I want to tell you a little bit about how to calculate the work when the pressure that's being opposing an expansion of a volume is held constant, as is probably the case in most cases if the work is done against the atmosphere. So the physical idea could be something like this. We've got a beaker here again, and a solution, and maybe there's some reaction going on that's forming bubbles. So we just imagine that after a certain period of time, enough bubbles have formed to effectively push the atmosphere out by some volume. And just for the sake of an example, we could just say that that's 1 liter that the volume has increased. So our expression for this is work is equal to minus the integral of the external pressure dV. And in this case, in which the external pressure is constant, as the atmosphere would be, I could say, well, that's minus the external pressure times the integral of dV, but the integral of dV is just the volume evaluated from the ending point to the starting point. Let's just say that we started off, I have an axis here of volume. Let's suppose we started off at 0 and we ended up at 1 liter. Okay, so the change in volume would be 1 liter, and I can finish this up like that. The work done is minus the external pressure times the change in volume. So what did we just say? I said that's 1 liter, but if I want to make this into an SI calculation, I would have to convert that into cubic meters, which turns out to be 10 to the minus 3 cubic meters. And what about the external pressure? Well, I said for, if it's atmospheric pressure, this would be about, let's say, 1 bar, but in SI units, that's we should convert that to pascals. So that would be 10 to the 5th pascals. Okay, so I have 10 to the 5th pascals times 10 to the minus 3 cubic meters. That's 100. Okay, so I get minus 100, and since this is an entirely SI calculation, I know that my answer, which has to have units of energy, it must be joules. So my answer for this expansion of going from 0 to 1 liter of expansion against atmospheric pressure at 1 bar comes out to be minus 100 joules. It's a negative, of course, because now the system has done work on the surroundings.